Among the Earth's many ecosystems, coral reefs are one of the most diversely populated. These aquatic cities are home to thousands of species. One of the most well-known of these is the Great Barrier Reef off the coast of Australia, which contains 3,000 reefs built by more than 360 species of hard coral. It's also shelter to more than 400 types of sponges, 1,500 unique species of fish, 400 varieties of mollusks, 500 types of seaweed, and 800 different types of other species like starfish and sea urchins. The benefits of coral reefs are not limited to the species that inhabit them or call them home. It is also somewhat of a protective barrier to coastlines, as the reefs provide a buffer for the ocean's waves before they hit the shore. Without this absorption, unprotected land experiences more powerful waves and can be destructive to unprotected seafront property, causing high costs in maintenance. There are also economic values to local coastal communities since the intricate corals are a draw for tourists. Reefs are frequented by groups of divers and snorkelers year-round that desire to catch a glimpse of these aquatic wonders. The diverse populations of coral are harmed or affected by many human interactions, including overfishing, boating, and water pollution. With these factors and the additional factor of climate change, the world's reef populations are being hit hard. Current climate change is causing the temperatures of the oceans to rise. In The Weather of the Future, written by Heidi Cullen, a senior research scientist, the development of the Great Barrier Reef is described. She brings to light that the most well-known underwater ecosystem is estimated to be between 6,000 and 8,000 years old and dates from the period during which the sea level is thought to finally have stabilized after the Ice Age came to an end. This stability of the ocean temperatures and levels became an ideal environment for the coral to thrive. So, if that's the ideal environment, what happens when that environment changes? What happens when the temperature of the ocean changes and the sea level rises? A good example of the temperature change on coral is the El Niño event of 1998, which caused a drastic warming of the Pacific Ocean. This in turn caused a massive bleaching event of the coral reef population in which 16% were effectively destroyed. This GIS map acquired from reefbase.org shows coral bleaching between the years of 1965 and 1995. This GIS map shows coral bleaching during the years 1997 to 1999. From these maps and data, it can be determined that the warming of the ocean caused by El Niño in 1998 had a dramatic effect on the rate of bleaching in the reefs. According to reefbase.org, many severely damaged corals have been able to rebuild and repopulate. Unfortunately, it is predicted that events like El Niño of 1998 could become more common due to the change in climate. Another threat to coral reefs in association with climate change is the rising ocean levels due to the melting of glaciers. The global average sea level rose by about 2 to 3 millimeters per year over the last half century. This graph shows the potential sea level change that could occur if drastic climate change continued. At this rate, many scientists suggest that sea level rise will have only small impacts on coral reefs because the projected rate of sea level rise are within the potential growth rates of most coral reefs. However, there is research that suggests that even though the rapid growth rate of many corals seems sufficient enough to keep pace with annual sea level rise projections, the overall net growth of reefs may be much slower than the growth of individual coral colonies. In addition, scientists are also concerned that the existing threats to reefs, such as increasing sea temperatures, ocean acidification, disease, and overfishing, reduce corals' ability to keep pace with sea level rise. In particular, ocean acidification may significantly slow the rates of coral growth, making it even more difficult for corals to keep up with the changes. So what is ocean acidification? Well, much of the carbon dioxide that enters the atmosphere dissolves into the ocean. As carbon dioxide in the ocean increases, ocean pH decreases or becomes more acidic. With ocean acidification, corals cannot absorb the calcium carbonate they need to maintain their skeletons, and the stony skeletons that support corals and reefs will dissolve. Already, ocean acidification has lowered the pH of the ocean by about 0.11 units, moving the ocean's pH from 8.179 to a current pH of 8.069, which means the ocean is about 30% more acidic now than it was in 1751. If nothing is done to reduce carbon dioxide emissions into the atmosphere, ocean acidification will increase and more corals will be damaged or destroyed. With these drastic changes occurring, it's tough to come to the conclusion of whether or not coral reefs such as the Great Barrier Reef will be able to adapt. To avoid more loss of the Earth's most diverse underwater ecosystem, there are possible solutions that would need to be taken into consideration. Reducing CO2 emissions in the atmosphere would greatly reduce the climb of ocean acidification and rising temperatures, as the largest contribution to climate change is the burning of fossil fuels. The human impact could be greatly reduced by looking at alternative sources of energy to power automobiles and provide electricity to homes. Although it would not be an easy adjustment, the ecological services that the reefs provide to humans and other species are something worth preserving. In correlation with reducing CO2 emissions, preventing overfishing in reef areas, and utilizing conservation laws would assist the reefs in adapting to climate change. These fascinating underwater cities are nothing short of extraordinary, the epitome of thriving oceanic life. To lose them would be detrimental to many of the species that rely on them, including coastal human populations. If climate change continues on its current path, causing the ocean temperatures and sea levels to rise, we could unfortunately see the consistent decline of the coral reef population.